The first thing we notice in number 4 is that all of the terms are even. So we can start by factoring out a GCF of 2, which leaves us with 2y squared plus 7y plus 3. Next, we're going to need to split the middle term. So remember, we multiplied the first term of 2y squared by the last term, which is 3. So we're looking for two things that multiply to make 6y squared. And those two things add to make 7y. Well, when we look at that, we can see 6y times y would be 6y squared, and 6y plus y is 7y. So that's how we're going to split that middle term. So let's do that. We have 2y squared plus 6y plus y plus 3. Now we want to group the first two and the last two together and write that as a sum. We can take the GCF of 2y squared and 6y out of the first set of parentheses. Well, those are both divisible by 2, and they each have at least one y. The top needs to be multiplied by an additional y, and the bottom by a 3 to get back to their original terms. So we factor out the 2y that they have in common and leave y plus 3 in the parentheses. Now at first glance, when we look at the last two terms, they kind of look like they don't have anything in common, but everything's divisible by 1. So they have a 1 in common. 1 times y is y, and 1 times 3 is 3. So we're going to factor out a 1, leaving a y plus 3. So we won't need the big brackets anymore because we're going to have the 2 on the outside, the y plus 3 that they have in common as our first term, and the 2y plus 1 as our second binomial. And that's our factored form. The next one, there's nothing that all of them have in common, but we do have two variables, so we need to be careful. We're looking for two things that multiply to make 17a squared b squared and add to make 18ab. Well, 17 doesn't have a lot of factors, so we kind of have to hope that 17 and 1 work. So 17ab times 1ab would give me 17a squared b squared. And 17 plus 1 equals 18, so they do work. We have a squared plus 17ab plus 1ab plus 17b squared when we split the middle term. We're going to group the first and the last two terms together. So we need to find a GCF for a squared and 17ab. Looks like the only thing they have in common is an a. The top still needs to be multiplied by an a and the bottom by a 17b. So we can factor out the GCF of a, and in parentheses we'll have a plus 17b. For the next two terms, 1ab and 17b squared, they each have a b in common. We need to multiply by an a, or a 1a, and we need to multiply by a 17b. So we can factor out a positive b, and in parentheses we'll have a plus 17b. They have this factor of a plus 17b in common, and the other factor is a plus b. We need to see what multiplies to make 60w squared and adds to make 19w. Now, the first thing I think of when I see 60 is 20w and 3w, but when those add together I get 23. So it's a little too much. So it looks like I'm looking for something a little bigger than 3. So the next thing that comes to mind is 10w and 6w, but that only adds to make 16. So I need something between 20 and 10. So let's try 15. Well, 15w times 4w would give us 19w. So that's the split of the middle term. So we've got w squared plus 15w plus 4w plus 60, and we can create that sum of two binomials. So looking at w squared and 15w, they have w in common. We would need to multiply the top one by w and the bottom one by 15. So that leaves w times w plus 15. 4w and 60 have 4 in common. The top would need to be multiplied by w and the bottom by 15. So we can factor out a positive 4, which will leave w plus 15 in parentheses. Since the w plus 15s are in common, we can factor that binomial out, leaving w plus 4 as our second binomial. We need two numbers that multiply to make 12z squared and add to make negative 13z. Well, 12z and 1z would make 13z, but we need a negative 12z and a negative 1z. So that's how we're going to split our middle term. Z squared minus 12z minus 1z plus 12. Z squared and negative 12z have a z in common. The top needs to be multiplied by z and the bottom by negative 12. We can factor out a z, leaving z minus 12. And then the negative 1z and the 12. Now, our first instinct might be to say that they only have 1 in common, but we're going to pull a negative 1. Remember, if the first term is negative, we always want to pull a negative sign. That'll leave a z and a 12 for what we need to, negative 12 for what we need to multiply by. We can factor out a negative 1, and that will leave a z minus 12 as their binomial. Since they both have this z minus 12 in common, I can factor out the z minus 12, and the other binomial will be z minus 1. In this next one, it looks like a binomial. So remember, we want to think about that as being 4x squared plus 0x minus 81. So this is kind of a large number to think about, but we're looking for two numbers that multiply to make negative 324x squared and add to make 0x. Well, if I'm going to multiply to make something and then add to make 0, I would have to have opposite signs and be the same number. So essentially, I want the square root of 324. So if I do negative 18x and positive 18x, that will multiply to give me negative 324 and add to give me 0. So that's how we're going to split the middle term. So we have 4x squared minus 18x plus 18x minus 81. The first two terms, 4x squared and negative 18x, have a 2 and an x in common. The top needs to be multiplied by another 2x and the bottom by a negative 9. So we can factor out the 2x, leaving behind 2x minus 9. 18x and negative 81 have a 9 in common. So the top would have to be multiplied by 2x and the bottom by a negative 9. So I'm factoring out a positive 9, leaving 2x minus 9 in common. They share that binomial of 2x minus 9, and that leaves behind a binomial of 2x plus 9. We have a similar situation in number 9. We need to put in that 0a in the middle so that we have a middle term to split. So I'm looking for two numbers that multiply to make 225a squared and add to make 0a. So this is a similar situation. I need to add to make 0a, so I know I need to have plus and minus the very same number. We recognize 225 as being one of our perfect squares, so 15a and negative 15a will be the two terms that split the middle. So we'll rewrite the problem as 25a squared plus 15a minus 15a minus 9. The first two terms, 25a squared and 15a, each have a 5 and an a in common. To get back to their original terms, I'd need another 5a and a 3. So when we've grouped, we're going to factor out a 5a and leave 5a plus 3. From the next two terms, negative 15a and negative 9, they have a negative 3 in common and would need to be multiplied by a 5a and a positive 3 respectively. So we'll factor out that negative 3, leaving 5a plus 3. They share that 5a plus 3 in common, so we can factor out that binomial GCF, leaving behind a second binomial of 5a minus 3. Now, your first instinct might be to just throw that 0x term in the middle, but start by noticing that 3 and 12 are both divisible by 3. So first, we'll factor out a 3, and then we can go ahead and put in that middle term. So we're looking for two numbers, two terms that multiply to make negative 4x squared and add to make 0x. Just as with the previous problems, we need a positive and negative of the same two numbers. So it looks like 2x and negative 2x should be the things that will multiply to get negative 4x squared and add to make 0x. So we're going to have a 3 outside the brackets. We're going to split that middle term and group the first two terms together and group the second two terms together. So x squared and 2x have a GCF of x. The top needs to be multiplied by an x and the bottom by a 2. So we're going to factor out the x that they have in common and leave x plus 2 in the parentheses. Negative 2x and negative 4 have a negative 2 in common. The top needs to be multiplied by x and the bottom by 2. So we can factor out a negative 2 and leave x plus 2 in parentheses. We have the 3 that we factored out in the beginning, the x plus 2, that's the binomial they share in common, and the x minus 2 that's left behind when we factor out that binomial GCF. Finally, we have a couple of word problems. The area of a rectangular painting is given by the trinomial a squared minus 6a minus 16. The painting's length is a plus 2. What is the painting's width? Okay, so we know that if we multiply two binomials together, we're supposed to get a squared minus 6a minus 16 because area is length times width. We're told that the length is a plus 2, and what we don't know is that other factor. So basically what we need to do is factor this trinomial. We would expect that one of the factors would be a plus 2, and so we could then find out whatever the other factor is would be the width. But knowing what one of the factors is can be helpful because this term times this term would have to equal negative 16. Well, 2 times negative 8 equals negative 16. So that would lead me to believe that I need a negative 8 in here. And if I look at this first term, a times a is a squared. Well, that a is already there, so I need the other a. So even without going through the work of factoring, we can determine that the width must be a minus 8. You could check that by multiplying the two binomials together, or you could check by just factoring the problem traditionally. 12 is similar, but they don't give us the heads up of already knowing what one of the factors is. The area of a rectangle is given by x squared minus 2x minus 35. Use factoring to find the possible dimensions. So we're looking for the length and the width in terms of x. So we're just going to factor. We're looking for two numbers that multiply to make negative 35x and which add to make negative 2x. Well, 7 and 5 are the most common factors of 35, and we know we want it to turn out negative. So if we do negative 7x times positive 5x, that would multiply to make negative 35, and it adds to make negative 2x. So we've got the split for the middle two terms. So we have x squared minus 7x plus 5x minus 35. And we can group the last two terms and the first two terms. X squared and negative 7x have an x in common. The top needs to be multiplied by x and the bottom by negative 7. The bottom two terms, 5x and negative 35, have a 5 in common. The top needs to be multiplied by x and the bottom by a negative 7. So the first binomial factors out an x, leaving an x minus 7. And the second binomial factors out a 5, leaving an x minus 7. We factor out the x minus 7 that they have in common and leave an x plus 5 behind. So the two dimensions are x minus 7 and x plus 5.